is what I showed you in my slides. I showed you this tunnel. I told you there is another 3 tunnels. I will show you the 4th one. And this is what I found out, that as we look at the Sphinx today.
For more than 4,500 years, a stone lion has been staring toward the eastern horizon at Giza, its human face fixed in silence, while kingdoms rose, collapsed, and disappeared around it. Carved directly from the limestone bedrock of the plateau, the Great Sphinx stretches roughly 73 meters from its paws to the end of its body and rises about 20 meters above the ground. But who built it, and why? When Grok AI was asked this very same question, its answer stunned everyone. Before we dive into that, let's first revisit what centuries of archaeological evidence have taught us. The lion that has been watching for 4,000 years. Unlike the pyramids beside it, it was not assembled from millions of separate blocks. Its enormous body was left behind when ancient quarrymen excavated the rock around a natural limestone formation, transforming the remaining mass into a colossal royal guardian. Well, at least that's the conventional wisdom. Egypt's Ministry of Tourism and Antiquities dates the monument to Egypt's 4th dynasty and says the evidence points to the reign of Pharaoh Khafra, who ruled approximately from 2558 to 2532 BCE. But there is a strange weakness in that seemingly straightforward explanation. No inscription from Khafra has ever been found declaring that he ordered the Sphinx to be carved. Instead, archaeologists have had to reconstruct the case from the landscape surrounding it. The Sphinx sits immediately beside Khafra's Valley Temple, while the lower section of his causeway runs alongside the Sphinx enclosure. Its own temple stands directly in front of the monument, creating an architectural relationship so tight that separating the Sphinx from Khafra's building program becomes difficult. Facial comparisons have also identified similarities between the Sphinx and surviving statues of Khafra. However, such comparisons are not, by themselves, conclusive proof of identity. Then the geology adds an even more remarkable piece of evidence. Between 1979 and 1983, Egyptologist Mark Lehner led the detailed mapping of the Sphinx, its temple, and Khafra's Valley Temple, working with geologist Thomas Eigner to trace the limestone layers through the complex. Their analysis found that many of the enormous limestone core blocks in the Sphinx temple correspond to geological layers exposed when the ancient quarrymen carved the Sphinx enclosure. Some of these blocks weighed as much as 100 tons. In other words, the builders were not simply constructing a temple beside an already ancient statue. They were excavating the stone around the Sphinx and using the material they removed to construct the architecture immediately in front of it. That discovery gives us a remarkable glimpse into how the monument may have emerged. As the quarrymen cut deeper into the plateau, different layers of limestone were exposed, and specific layers correspond to different parts of the Sphinx and to blocks incorporated into the surrounding temples. ERA's reconstruction suggests that the Sphinx and its temple were created as part of the same quarrying and construction sequence, with the Sphinx likely among the final elements added to Khafra's complex. Some enormous blocks were even abandoned unfinished. And yet, this is where the story becomes uncomfortable. The archaeological evidence creates a powerful case for Khafra, but another group of researchers has looked at the same monument and focused on something completely different: the way its stone has weathered. Geologist Robert Schoch and researcher John Anthony West argued that parts of the Sphinx enclosure display erosion patterns more consistent with prolonged rainfall than with simple wind and sand. If that interpretation were correct, it could push some of the monument's history back into a much wetter period of Egypt's past, long before Khafra's reign. So the first mystery is not simply who carved the Sphinx. The deeper question is whether every part of the stone's story fits that date. Because the Sphinx has been repaired, buried, weathered, reinterpreted, and studied for centuries, the monument may be telling several stories at once. And the moment you stop looking at the face and start looking closely at the stone itself, the apparently simple story of Khafra begins to crack. The pharaoh we thought we knew. The Sphinx may look like a monument built for one king, but the archaeological story behind it is far more complicated. The strongest evidence places it within the 4th dynasty building program at Giza, during the reign of Pharaoh Khafra, whose pyramid dominates the plateau behind it. Khafra's complex followed a recognizable Egyptian pattern: a pyramid temple, a long causeway, and a valley temple. But at Giza, something unusual was added to that arrangement. The Sphinx and its own temple became part of the same monumental landscape. Archaeologists, therefore, do not identify Khafra as the builder simply because the face resembles his statues. The case comes from the entire landscape. One of the researchers who spent decades trying to reconstruct that landscape was Egyptologist Mark Lehner. Between 1979 and 1983, Lehner mapped the Sphinx, its temple, and the nearby Khafra Valley temple stone by stone, working with geologist Thomas Eigner to understand the geological layers beneath them. What they found was remarkable. Some of the enormous limestone blocks forming the core of the Sphinx temple contain geological layers that match the layers still visible in the Sphinx quarry. The ancient quarrymen had literally cut through the bedrock surrounding the Sphinx, removed enormous blocks, and used that same stone to build the temple in front of it. Some blocks weighed as much as 100 tons. This geological fingerprint connects the Sphinx and its temple to the same quarrying operation in a way that a resemblance between two faces never could. The construction sequence makes the connection even harder to ignore. Era's archaeological reconstruction indicates that Khafra's Valley Temple and Causeway came before the Sphinx Quarry and Sphinx Temple. The two temples also occupy the same prepared terrace, while the Sphinx Quarry forms part of the landscape alongside the causeway. This suggests that the Sphinx was not an isolated statue that happened to stand beside Khafra's monuments. Instead, the evidence indicates that it was incorporated into the later stages of the king's building program. Lehner's conclusion is carefully worded. Khafra most probably created the Sphinx, although he has acknowledged that Khufu, Khafra's predecessor, might have initiated some of the work. Even the mainstream archaeological case therefore contains a small but important uncertainty. And then the story jumps forward roughly 11 centuries. The original 4th Dynasty monument had become something else entirely. During the 18th Dynasty, the Sphinx was associated with the solar deity Horemakhet, meaning Horus in the horizon. Pharaoh Amenhotep II built a temple beside it, and his son Thutmose IV later placed the famous Dream Stela between its paws. The monument had by then become so ancient that it was no longer simply remembered as part of Khafra's royal construction program. It had acquired a sacred identity of its own. In fact, the Dream Stela tells an extraordinary story. Thutmose IV described sleeping near the Sphinx when the monument, represented as a divine being, appeared to him in a dream and promised him kingship if he cleared the sand covering its body. Archaeological evidence supports the idea that the statue required restoration by this period, and Lehner's mapping indicates that some of the later restoration masonry came from Khafra's own causeway. Even the famous Dream Stela itself was apparently reused from a doorway lintel associated with Khafra's pyramid temple. That means the Sphinx we see today is not simply a frozen snapshot of the 4th Dynasty. Its limestone has been repaired repeatedly. Its religious meaning changed, and parts of later restoration still cling to the ancient core. The monument was already ancient when Thutmose restored it, and it continued deteriorating for centuries afterward. But what if the stone itself preserves evidence of a history older than the pharaohs? Because the strangest clues aren't written in hieroglyphs. They may be hidden in the scars left behind by water, wind, salt, and time. The stone that remembers rain. In 1990, Robert Schoch traveled to Egypt with researcher John Anthony West to examine the Sphinx from a geological perspective. Schoch expected the conventional 4th Dynasty date to fit the evidence. Instead, he focused on something archaeologists had not made the center of the debate: the deep, rounded, and vertically undulating weathering patterns carved into the walls of the Sphinx enclosure and parts of the body. Schoch argued that these features were characteristic of prolonged rainfall and runoff rather than ordinary wind and sand erosion. If that interpretation was correct, the implications were enormous, because the Giza plateau had become increasingly arid long before the classical Egyptian civilization that built the pyramids. The argument became explosive, because Egypt's climate really had changed dramatically over time. The Sahara was not always the desert we see today. During earlier phases of the Holocene, North Africa experienced much wetter conditions, with monsoonal rainfall extending farther north than it does now. Schoch therefore proposed that the oldest portions of the Sphinx could date back thousands of years before Khafra, with his later work pushing the possible age toward the end of the last ice age. This was around 10,000 BCE. But this is where the crucial distinction begins. Rainfall weathering is evidence that must be interpreted. It is not a clock. Even if water contributed to the erosion, determining exactly when the damage occurred is a separate problem. Other researchers have challenged Schoch's interpretation, pointing out that limestone at Giza is not uniform. Different geological layers contain different weaknesses, joints, and fractures, while salt crystallization, groundwater, humidity, wind, and occasional rainfall can all contribute to deterioration. Geologist K. Lalgari and colleagues argued that the Sphinx's weathering could be explained without pushing its construction thousands of years into the past. This matters because the debate is not really water versus no water. Water unquestionably affects limestone. The real question is how much water, for how long, under what conditions, and whether the observed erosion can establish a construction date. And that is a much harder question. Then, in 2023, Samuel Borey, Scott Weedy, and Leif Ristroff published Sculpting the Sphinx in Physical Review Fluids. Instead of excavating ancient Egyptian records, they built experimental landscapes using soft clay, containing harder material, and exposed them to flowing water. As the water eroded the softer material around the harder sections, surprisingly recognizable shapes emerged, including forms resembling the posture of a crouching lion. Their experiment demonstrated that natural erosion can produce a lion-like starting form from which human sculptors could have worked. And suddenly, the question becomes stranger. What if the ancient quarrymen did not begin with an ordinary block of limestone and simply decide to carve a lion? What if the bedrock itself had already produced a shape that looked enough like an animal to inspire them? The Sphinx was carved from a geological formation whose layers weather at different rates, meaning some of its basic contours were dictated by nature before the sculptors ever touched the stone. The possibility does not make the monument less impressive. It may make the ancient builders more interesting. Perhaps they recognized a natural formation and transformed it into something deliberate. But the rainfall theory still leaves one enormous problem. Even if prolonged precipitation created some of the erosion, how old does that actually make the Sphinx? Schoch's interpretation points toward a much older monument. Meanwhile, mainstream experts place the Sphinx within Khafra's complex. The head that doesn't seem to fit stand in front of the Great Sphinx, and one detail is almost impossible to ignore. The body is enormous, a crouching lion stretching across the limestone, yet the human head above it seems strangely small. The proportions are so unusual that they have fueled one of the Sphinx's most persistent mysteries. Was this always meant to be a human-headed lion? Or did the monument begin as something else? Some alternative researchers have proposed that an earlier monument may have carried a lion's head, and that the present human head was carved later. You see, the Sphinx was not carved from a uniform block of limestone. Its body and head were shaped from natural geological layers of different hardness and quality, and those layers imposed limits on what the ancient sculptors could safely remove. The head sits on a higher and somewhat more resistant section of the formation, while the body extends through softer strata that weather differently. ERA's geological mapping shows the natural limestone beds running directly through the monument, making it clear that the builders were working with the geology rather than an ideal sculptor's block. The apparently undersized head, therefore, does not, by itself, prove that an earlier lion was recarved. It may simply reflect what the builders could carve from the stone they had. But there is something that makes the recarving theory difficult to dismiss completely. The Sphinx really was modified after its original construction. The monument's surface carries evidence of repeated restoration because its limestone deteriorated badly over thousands of years. ERA's surveys document ancient repairs beginning at least in the New Kingdom. with later restoration continuing through Roman times and into the modern era. In the 1980s, pieces of the native rock itself broke away, including a substantial section of the right shoulder in 1988. This means the Sphinx we see today is not simply the untouched product of 4th dynasty sculptors. One of the clearest examples is the famous beard. A surviving limestone fragment now held by the British Museum is dated to Egypt's 18th dynasty. Museum curators note that the beard was probably added during the restoration associated with Thutmose IV, roughly 1,000 years after the Sphinx was created. Its curved form identified the figure as a god rather than a king, while the original royal beard would have been straight. Fragments of the beard were discovered between the Sphinx's paws during 19th century excavations, proving that at least one conspicuous feature of the monument visible today was a later addition. Even the missing nose carries a warning about how easily Sphinx history becomes mythology. The most famous version claims that Napoleon's soldiers blasted it off with cannon fire after the French arrived in Egypt in 1798. But the timeline makes that impossible. Danish explorer Frederik Louis Norden had visited Egypt in 1737 and 1738, more than 60 years before Napoleon's campaign, and his detailed drawings, published in 1755, already showed the Great Sphinx without its nose. Norden even commented on the monument's damaged face. An 18th century drawing from 1778 provides another piece of evidence. Its accompanying description refers to the nose as already damaged. The Sphinx had lost its nose long before Napoleon ever reached Giza. So who did it? The most frequently cited historical account comes from the Egyptian historian al-Makrizi, who wrote in the early 15th century that a Sufi ascetic named Muhammad Sa'im al-Dahr deliberately damaged the Sphinx in 1378 after becoming angered by people making offerings to the monument. The account cannot be independently verified, and the exact circumstances remain uncertain. But it fits the evidence for deliberate damage better than the idea of centuries of natural erosion simply knocking the nose away. No fragments of the nose have ever been recovered, so unlike the Sphinx's beard, its missing features cannot be reconstructed with certainty. Napoleon's actual connection to the Sphinx was very different, and in some ways even more consequential. When he invaded Egypt in 1798, he did not arrive with soldiers alone. More than 150 scholars, engineers, artists, and scientists accompanied the expedition, recording the country's monuments, landscapes, wildlife, and antiquities. Their work eventually became the enormous Description de l'Egypte, a multi-volume publication packed with detailed illustrations and observations. The campaign also produced the Rosetta Stone in 1799, which would later become essential to Champollion's decipherment of Egyptian hieroglyphs. If anything, the French expedition brought ancient Egypt into the European imagination on an entirely new scale, and the detailed drawings and publications that followed helped transform scattered ruins into the subject of serious scientific study and enormous public fascination. What we know for a fact is that the Sphinx had already been losing pieces, disappearing beneath sand, and undergoing repairs long before modern tourists ever reached Giza. Then there is the inventory stela, a much later Egyptian inscription that has become ammunition for those arguing that the Giza monuments were older than conventional chronology allows. Alternative researchers have interpreted its references to the Sphinx and other monuments as evidence that they already existed before Khufu. But the stela was created centuries after the 4th dynasty, so it cannot function as a contemporary construction record. At most, it preserves a later tradition whose historical meaning remains debated. This is where scholars start filling the gaps. The lion in the sky. The Sphinx does something remarkably simple. It looks toward the eastern horizon. But when Robert Bovell and Graham Hancock began asking whether that direction had been chosen for a reason, the monument suddenly became part of a much larger celestial puzzle. The Sphinx's eastward orientation fits naturally within ancient Egyptian religious symbolism, where the rising sun, the eastern horizon, and the daily cycle of death and rebirth were fundamental ideas. That fact alone is not mysterious. The mystery begins when you ask what else might have been rising over that horizon thousands of years ago. In their book, The Message of the Sphinx, published in 1997, Boval and Hancock argued that the lion-bodied monument was connected to the constellation Leo, and that its orientation preserved an astronomical message from a much earlier age. Their argument depended on one of astronomy's slowest clocks, the precession of the equinoxes. Earth's rotational axis is not fixed, like the axis of a perfectly stationary spinning top. It slowly changes its orientation over a cycle of roughly 26,000 years, causing the positions of the stars relative to the equinoxes to shift gradually over millennia. That means an ancient sky can be reconstructed mathematically. Boval and Hancock argued that around 10,500 BCE, the constellation Leo occupied a significant position along the eastern horizon in relation to the Sphinx gaze. They proposed that this was not simply a coincidence, and this is where the theory becomes genuinely seductive. Picture the Giza plateau around 10,500 BCE, not as the desert landscape familiar today, but as a world thousands of years removed from the pharaohs traditionally associated with Giza. A stone lion faces east, while Leo rises along the horizon, and above the same landscape, the stars are slowly moving through the enormous celestial cycle created by Earth's precession. To Boval and Hancock, the coincidence was too precise to ignore. Their theory connected the Sphinx to a much broader interpretation of Giza, in which the three Great Pyramids represented the stars of Orion's belt, while Orion itself was associated with Osiris in ancient Egyptian religious thought. But there is a critical problem hidden inside that beautiful alignment. A mathematical alignment can tell us where the stars were. It cannot, by itself, tell us what the builders intended. There is no surviving 4th Dynasty inscription stating that the Sphinx was designed as a terrestrial image of Leo, no ancient construction document describing precession, and no text saying that the monument was deliberately positioned to encode the sky of 10,500 BCE. Even proponents of archaeoastronomical interpretations acknowledge that establishing intention is the difficult part. The sky can be reconstructed with extraordinary precision, but the minds of people who lived thousands of years ago cannot be. The theory becomes even larger when the Sphinx is placed into the so-called sacred geometry of Giza. Boval's Orion correlation theory proposed that the three major pyramids correspond to the three stars of Orion's belt, while the Milky Way was interpreted as a celestial counterpart to the Nile. The idea is not that ancient Egyptians knew nothing about astronomy. They unquestionably observed and incorporated celestial bodies into their religion. The real question is whether the entire Giza plateau was deliberately engineered as a map of the heavens. That distinction matters because individual astronomical symbolism is one thing, but a vast prehistoric blueprint encoded across an entire landscape is something much more difficult to establish. And there is an even more fundamental problem. Patterns are remarkably easy to discover after the fact. Give researchers enough monuments, stars, directions, angles, and dates, and some relationships will inevitably appear striking. The stronger test is whether the pattern was predicted before the measurements were examined, whether alternative explanations were ruled out, and whether independent researchers can reproduce the result. That is why the Leo theory remains controversial rather than accepted archaeology. The alignment can be calculated. Its meaning has to be argued. Yet once the Sphinx is moved from roughly the time of Khafra to 10,500 BCE, the entire story changes. The monument is no longer merely an extraordinary Egyptian statue. It becomes a possible survivor. It hails from a world that existed before dynastic Egypt itself, the civilization beneath the sand. The deeper you go into the Sphinx mystery, the stranger the story becomes. One of the most famous claims is that somewhere beneath the monument lies a hidden hall of records, supposedly containing the lost history of Atlantis. But this story does not come from ancient Egyptian inscriptions. Its modern origin is largely Edgar Cayce, the American clairvoyant, whose readings in the 20th century claimed that survivors of Atlantis preserved records beneath the Sphinx. In one of his readings, Cayce described a sealed chamber containing a record of Atlantis and said the entrance was connected with the Sphinx. Interestingly, there really have been investigations beneath and around the Sphinx. Geophysical techniques have detected subsurface variations and possible cavities or voids, but an underground anomaly does not automatically become a chamber, and a chamber does not automatically become a library. Even the Edgar Cayce organization acknowledges that its interpretation of certain underground features is tied to Cayce's readings rather than established archaeology. And then there is Atlantis itself. The story is ancient, but not as ancient as the Sphinx. Whether Plato intended Atlantis as literal history, philosophical fiction, or some combination of the two has been debated for centuries. Ancient Egypt itself provides another tempting piece of the puzzle. The idea of Zep Tepi, often translated as the first time, a primordial era associated with the establishment of divine order. But that leap is important. Egyptian mythology genuinely contains traditions about a primordial age. It does not provide archaeological proof of a lost civilization possessing technology comparable to modern society. Then comes a real catastrophe from the archaeological record. Around 12,900 years ago, the Earth entered the Younger Dryas, an abrupt return toward colder conditions that interrupted the warming trend following the last ice age. Evidence for the event appears in ice cores, ocean sediments, and terrestrial deposits, and scientists continue to debate its precise causes. One leading explanation involves disruptions to North Atlantic circulation caused by fresh water entering the ocean, while other proposals include volcanic activity and extraterrestrial impacts. The controversial Younger Dryas impact hypothesis goes further, proposing that fragments from a comet or asteroid struck multiple regions roughly 12,800 years ago. Some researchers have reported platinum anomalies, high-temperature spherules, and other unusual materials in sediments, while other scientists dispute the interpretation and whether an impact caused the climatic event. This is where the lost civilization theory becomes almost irresistible. Imagine a civilization existing before the Younger Dryas, followed by abrupt climate disruption, rising seas, and the destruction of coastal settlements that are now underwater. Then add monuments that appear unexpectedly sophisticated, and suddenly the Sphinx can be placed inside a much larger story. But there is one archaeological discovery that genuinely changed the conversation about prehistoric societies: Göbekli Tepe in southeastern Turkey. Dating to roughly 11,500 years ago, its monumental T-shaped limestone pillars demonstrated that hunter-gatherer communities were capable of organizing an enormous communal construction far earlier than many older models had expected. But Göbekli Tepe proves something much more interesting than Atlantis. It proves that prehistoric people could organize complex societies, quarry enormous stones, create monumental architecture, and express sophisticated symbolic ideas without cities, kings, or metal technology as we traditionally imagine them. It does not prove a technologically advanced global civilization, an Atlantean empire, or a sphinx dating to 10,500 BCE. Nevertheless, writers such as Graham Hancock have used Göbekli Tepe, the Younger Dryas, flood traditions, and ancient monuments to construct the hypothesis of a lost Ice Age civilization whose knowledge supposedly survived through later cultures. The evidence for that claim remains absent, but the underlying question keeps returning in different forms. If ancient people accomplished something we find difficult to explain, where did the knowledge come from? The Sphinx sits perfectly at the center of that question. The older you make the monument, the more theories you can attach to it. And now, we have artificial intelligence in the equation. What did Grok actually discover? So, was Grok given geological surveys, laser scans, climate reconstructions, seismic information, and astronomical data to investigate who built the Great Sphinx? Even if that were the case, what exactly would Grok analyze in such a situation? There is a claim that there is a 94.7% confidence that rainfall erosion shaped the Sphinx. Yet, the calculation, dataset, variables, and methodology behind that figure are not provided. That matters because researchers already disagree over how rainfall, groundwater, salt wind, and differential limestone hardness contributed to the monument's weathering. The other alleged discoveries also have precedence. Robert Schoch and John Anthony West argued for rainfall erosion, indicating an older Sphinx, while Graham Hancock and Robert Bovell proposed an astronomical connection between the Sphinx and Leo. If Grok reached similar conclusions, we need to know whether it independently derived them from raw data or simply synthesized theories that already exist in the Sphinx literature. You see, an AI can compare competing arguments, identify patterns across large amounts of information, and construct a remarkably persuasive hypothesis. But the confidence of the answer does not turn the hypothesis into physical evidence. A percentage generated by a model is only meaningful if we know what data produced it, what methodology was used, and whether independent researchers can reproduce the result. Consider how dramatically the answer can change depending on the question. Ask, did Khafra build the Sphinx? And an AI can summarize the archaeological case. The Sphinx sits within Khafra's architectural complex. Its temple is connected to the same geological quarry, and the surrounding monuments form a coherent 4th dynasty landscape. Ask instead, what evidence proves the Sphinx is 10,000 years old? And the same system can gather the rainfall erosion arguments, astronomical theories, and climatic evidence used by proponents of an older date, and construct the strongest possible case for that conclusion. The underlying evidence has not changed. The question has, well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.